Hi, today we talk about process control action. It's a closed loop process control action. Closed loop process control action, sometimes we call feedback control. Is the process control look like this? Is how 4 components: controller, actuator is control wall including actuator and wall body, and the measure device is process manufacture process. Okay, measure device including level transmitter, the temperature transmitter, flow transmitter, all the detect signal. This signal just analog signal, is not the input or not the digital input signal. Okay, and this feedback go to the controller, is measure device, detect feedback, go to the controller, he compares set point, is decide, use the PID, decide what's the output, go to the actuator. Is control output signal, go to the actuator. Then actuator to do action, actuator action to decide the process line. So in all of this is important is actuator action. It's important he decide all the process line is safety or fail. Okay. So control wall is we have fail model, is called fail safe. This is important parameter of control wall. Just fail safe. What means fail safe? Fail safe means if all the system is no signal, for example, no air signal, no electric signal, the control wall should be go to the safe position. Safe position maybe the wall is open, completely open, wall may be completely closed, depending on your process control system. Process system is called fail safe. Fail safe we sometimes call, we use FO, fail open, FO, or FC, fail close. Fail safe is called FO or FC. FO is equal to air to open, air to close. Okay, next. First we talk about the control wall is fail, is direction, is action, is called direction action, reverse action. Control wall is what means direction action? If an input signal is increased, output signal increase the direct action. This reverse action means input increase, output decrease. Control wall including the actuator and wall body. So control wall have 2 actions. So actuator still have 2 actions. Is direct acting actuator or reverse acting actuator. Direct acting actuator means if you push down on the steam with an increased pressure, if you have an input signal air, an increased pressure, if the actuator should be pushed down, it go down, it's called direct action. Reverse action means that if an increased pressure is the steam, is actually steam should be up. Okay. Its wall body have direction acting body. If your steam is lift, it's open, the direction acting. If your steam is lift, its valve is closed, is reverse acting. Okay, so actuator have two action, valve body have two action. So all the control valve have four action. This compare have two of this is actuator and the valve body combining have two position, two action. Okay, is direction action control valve and reverse action control valve have two type. Okay, like this one. For example, this one is more actuator. This actuator, this valve body, is actuator is push down. Is air is pushed down. Air actuator steam go down. Is direction. Oh, here's air. Oh, here's air. Okay, sorry. Here's air. It's air go down, go up. Air go up. It's steam actuator. Up is called reverse actuator. So its valve body is direction acting get. Is go up. Is open. Go up. It's open. Is direction acting. So this reverse acting actuator, direction actuator, the valve body. So combine go to the air to open. Its control valve is air to open. That means fail to close. Okay, air to open is the ATO. Fail to close is called FC. This first kind. Second, look this way. Is air go down, air increase. Is actuator valve is go down. Its direction action is valve, not actuator. Direction acting, direct acting actuator. But its steam go down, its valve is closed, so it is direction acting valve body. So is combining is the control valve is air to close, fail to open. These two kinds actuator control valve is very popular. Its valve almost time is the valve body almost time is direction action. Okay. Next one. It's third kind is the actuator control valve action. Look, is air line is here, air line is here. Air going inside is actuator, is steam actuator steam up, so is reverse actuator. It's look. Here is valve body is completed before this one. Okay. It's steam up. The floor is closed. Okay. Its valve body is closed. It's reverse acting. Here the same thing, reverse acting. So it's the reverse acting actuator combining reverse acting actuator body is air to close. It's look, air going inside, air increase, its valve is up close. It's fail to open. It's no signal, no air, he should go down. It's open. Okay. Here is actuator is direction actuator. Its valve body is reverse acting actuator. combining is direction actuator, combine is reverse acting wall body is air to open. No, is air go inside and increase, its wall is open. The fair to close. Okay. This four kind is the control wall. Okay. Most time is wall body is direction acting body. This kind is reverse acting body, not popular. Okay. So if we call direction action is positive, reverse action is negative. So we can go to here. Is positive. Oh, this is positive. So is the combining is the control wall is positive. Is direction action. Reverse positive is actuator. Negative is control wall. Is control or is wall body. Is control wall is negative. Is here is actuator is negative. Is wall body is positive. So he is negative control wall. Is reverse action. How this called direction action, reverse action, reverse action. For this one, last one is the actuator is negative, reverse action is wall body reverse action. So here the control wall is positive, is direction action. Okay, same thing is mass positive, multiple positive equal to positive, positive multiple negative equal negative. Okay, so here is active positive. Wall positive is called fair to close. Okay, fair to close ATC is positive. It's field open. It's positive, negative. It's fair to open. It's fair to close. Okay, all the same thing. Okay, they just summarize all this one. Okay. So in the PID, we often use control wall. This one is called fair to open. If you write down fair to open, FO, fair to open, or if you look like this, arrow is up, it's fair to open, it's fair to close. Okay. When we analyze action in every loop, at first we should think about wall safety condition, so that the process system is safety. Then we think about other device to make sure it's a negative feedback loop. Okay. First we should think is all the control wall. Make sure this process line is safety. For example, this engine is a fail. What's the make sure is safety? Should be is fail all go inside, maybe something is wrong. Should be make sure he's cool down. How to cool down is fail to close. Also air to close. The fail to open. No signal here should be open. This wall should be open. Okay, cool all is go inside. Okay. Cool open. If your here is fail to open, air to close, then we decide controller, transmitter, transducer, every component, what's the corresponding to the fail to open. Okay, for example, if temperature transmitter temperature too high, if your temperature transmitter output should be negative. It should be, for example, let me see how to say this way. If this engine temperature too high, temperature transmitter detect high signal. What signal he should send the controller? If your temperature transmitter is direction action, should be output transmitter is increase. Okay, temperature too high, increase. On the controller, if your still is direction action, is output should increase. So temperature too high, signal go to the temperature controller is high. So go to the TY, this I2P is position, okay? Or is I2P is transferred to the L to signal go to the L PSI. If you here too high, here too high, here is too high, all this direction, if all this direction is direct action, here is still high direct action, here is high pressure, is go down, this fail to close air to, or fail to open air to close. So here should go down, coolant should is decrease. That's impossible. If a temperature so, we should change this one TIC on the TT is the direction. If your here is temperature too high, temperature transmit should reverse action. Its output should be go decrease. If your decrease temperature controller is direction, so this one is here is go down. Here's go down. Here's down. Here's down. So it is open. Okay. Or here's an increase. Here's direction. Reverse direction. Okay. Here is open. So most time we use the controller to decide action. Okay. Sometimes we should always use this. Most time we temperature transmitter always use direct action. Here, look, is never is coming, is water is coming, is control valve should be open. It's no signal. If you're not close, fail to close, is water is come out. Okay. So how to do this way? We first use the never transmitter positive. Never is up, signal is up. Signal is up, never controller should be reverse action. Reverse action is the input up, input increase, output decrease. So this decrease is valve is open. Okay. Same thing is the boiler. First we analyze is control valve. There is air to open. This one is air to close. Air to open. If your no signal should be fill is close. Okay, fill the close. If your no signal come here is fill should open, is water is come out. Make sure here is boiler is safety. So how to make sure here's air to open, how to make sure here's air to close. So that transmitter should be reverse. Controller should be direction. And so that's why I make that it's fail to close. Here is follow transmitter should be positive direction action. Controller should direction action. So here is make sure it's ATC. Okay. Same thing this way. It's the reverse action is all the next this way. Okay. Is control all the same thing this way. Okay. All the same thing. Is how to control transmit. First you decide is control wall or what's the make sure hit safety position. Okay. Like this. Its Q is floor. Is a floor increase. Floor increase, press transmitter increase. Press transmitter increase if the controller increase. Make sure here is an increase. If your floor too much, should be open. Okay. Decrease this is a 5 to open. Okay. This look like this. Floor open. Increase, press transmitter, increase, controller should decrease. Is reverse. This one increase the flow, transmitter direction action. Controller is reverse action. Position should be direct action. Control watch close. Or is flow is increase, transmitter is an increase. Controller, if you increase, position should be decrease. If your controller's direct position should be reverse direction. So wall just close. Is safety is wall is closed. Yeah, no signal. It should be closed. Fail to open. Air to close. Okay, fair should be open. Okay, that's it. The fact is that the field configuration is very important because good safety engineer demand that the risk of factors of the process determine proper wall field model rather than control system convention or habit. Also, you have to think about the whole system is negative feedback. Most of the time, we configure the controller action and the control wall field mode to make sure the system safety. Okay, that's it. Important just we should make sure its system is all system is safety. How to make sure it's safety to actuate important is decide all the system safety. Okay, if you want to actuate the safety field safety position, so controller measure device should be combining to make sure you actuate the safety. Okay, that's process control important things. Okay, thank you very much.